Good evening, good afternoon, good morning, depending on when you're watching this. This is Mr. Malaji, and I will be taking you through this video on trinomial factorization. So, at this point, you're at grade 10, and at class 9 or grade 9, you would have learned about trinomials and how to factorize these. At this level, the whole idea is to master them because trinomials pop up in almost everywhere in mathematics. So it is very important for you to know how to factorize them. So let's take you through the video. This video will go through, we're going to first look at the different types of trinomials. I've put them in different categories, and then we're going to look at each category, how to solve at least 3 examples within that. So I've listed them as easy trinomials, intermediate trinomials, and lastly complex trinomials. Let that word not deter you. Complex just it's just a category. It does not mean they're actually that difficult to solve. So relax and stay with me. All right, so what are trinomials? Trinomials is this expression that has 3 terms. So any expression that has 3 terms that looks like this, where the first term is some coefficient with an x squared plus some coefficient with an x, lastly plus a constant. So these operations there might change, and these coefficients there might change, but as long as you have 3 terms and the first one has an x squared to it, the second one has an x, and the last one is a constant, we call that a trinomial. So let's look at different types of these and how we're going to go about to factorize each of these. So I've listed them in 3 categories. The first one is the easy trinomials, and they're called easy trinomials because that a value is always 1. So that coefficient of the x squared that you see in front will always be 1. And if it's 1, sometimes we don't even put that 1. So whenever you just see x squared by itself or a squared by itself or whatever variable squared by itself with the x component and the constant, then you know it's definitely an easy trinomial. Then the intermediate trinomials, these trinomials are where the a value is not 1. But why are they intermediate? They're intermediate because if you just look at it, there is always a common factor that you can take out. So you have to stare at it for a bit, and the example that I gave to you, you can clearly see that I can take out 2 as my common factor, and then I can factorize my trinomial. The last ones are the complex trinomials. And how do we notice these, or how do we identify these? These ones are also where a is not equal to 1, but when you're looking at these ones, you cannot take out a common factor. So if you look at the expression 3x squared plus 19x plus 6, you will see that there is no common factor that we can take out. 3, for example, does not go into 19, even though, yes, it does go into 6. So the fact that it does not go into every single one of those coefficients means we cannot take out a common factor. So let's get into how do we factorize each of these. All right, so let's look at the easy trinomials. So if you're looking at, sorry. All right, let's look at an example of an easy trinomial. So we have x squared that is adding a 5x that is being added by a 6. We are asked to factorize this expression. So what do we do first? We open our two brackets first, our two pairs of brackets. Then we look at this first term. If we take that x squared and we square root it, what do we get? You should know by now that if you square root something that is squared, you just get the number. So if I square root 2 squared, I just get 2. If I square root x squared, I would just get x. That x there would go in the first position of both brackets, as you see in the picture. As I was saying, the x there would go into the first position of both brackets, right? So now you've gotten the first part, and then the next part is now we're looking for factors of 6. These factors of 6 are obviously going to multiply to give you 6 because they're factors of 6, but we need them to add to give me this positive 5 that you see in the middle coefficient. So whatever factors that we get of 6, they need to add to give me a positive 5. So I know a 1 and a 6 are factors of 6, but those do not add to give me a positive 5. What does add to give me a positive 5 is a 3 with the 2, because a 3 times a 2 gives me a 6, and it adds to give me a 5. So once I've gotten my factors, I put the positive 3 in there, and I put the positive 2 in that bracket. And there we go. That is that question factorized. All right, let's have a look at another question. Another example. So what if we have x squared minus 7x plus a 12? How will we factorize this? Again, you open your two brackets, right? If you remember from the first step, you always take this guy, which is an x squared, and you square root that guy. And if you square root that guy, you're going to get x. That x goes in the first position of both brackets. And then we look at the factors of 12. So again, what are factors of 12? Factors of 12 are two numbers that are going to multiply to give me a 12. But these two numbers, they have to multiply to give me a 12, but they have to add to give me that middle coefficient there, which is a negative 7. So let's just think to ourselves. If these numbers are adding to give me a negative 7, the only way I would ever get a negative 7 is if both of them are negative. Alright? Because a negative times another negative would therefore give me a positive 12. So think to yourself, what are these numbers? I could multiply a 2, right, a negative 2, and then negative 6 to get a 12 for positive 12. But are these going to add to give me a 7? No. I could also multiply a negative 3 and a negative 4. So those are the ones we're looking for, because a negative 4 plus a negative 3 a negative 4 plus a negative 3 would give me a negative 7. So those are the factors we're looking for. So the negative 4 goes in there, and the negative 3 goes in there. All right, now let's look at another example. We're still on easy trinomials. Let's look at something that says d squared minus 2d minus 48. So this is still a trinomial. We still open our two brackets. Then we square root the d squared, and by now you should be able to see that it gives us a d. And then we're gonna look for the factors of a negative 48. If it's a negative number, one of the factors needs to be positive and one of them needs to be negative. And what do these factors need to do? These factors need to add to give me a negative 2. So which numbers, if I add them, that multiply to give me 48, but if I add them, I get a negative 2. So I've been doing trinomials for a while now. I know if my middle coefficient, which is the negative 2, is negative, then whatever factor, the bigger one needs to be the negative one. Whatever factors I find, the bigger one needs to be the negative one. So I'm thinking to myself, a 2 and a 24. So there's positive 2 and a negative 24. Positive 2 and a negative 24. Do those add to give me a 2, a negative 2? They clearly don't. So I discount that and look for other factors. All right. I could think there could be a 4 and a 12. 4 and a 12, positive 4, negative 12. Still, these do not give me a negative 2, so those are not the ones I'm looking for. Sorry. Yeah. So let's look at 6 and a negative 8. So 6 and a negative 8 are the perfect factors we're looking for because they add to give me a negative 2. So I put my positive 6 in there, and I put my negative 8 in there. And there we go. We've solved this simple trinomial. So we looked at simple trinomials. I hope that makes sense, and I hope at least you are following on the procedure that we do when we're solving these. So let's look at the intermediate ones. Intermediate trinomials. So these intermediate ones, remember, we can always take out a common factor. So let's look at an example of these. What if we have a 2x squared minus a 2x minus a 12? So this, we should all be able to clearly see that the 2 there, the 2 there, and the 12 here all have a common factor. And what is that common factor that I can take out? It's a 2. So let's first do that. Take out our 2, open our bracket. 2 times what would give me back to a 2x squared? 2 needs to multiply with an x squared to give me back to a 2x squared. 2 times what would give me back to a negative 2x? It needs to multiply with a negative 1x. And lastly, 2 times what would give me back to a negative 12? It has to multiply with a negative 6. So we've taken out our common factor. We keep it outside there. And the guy inside of the bracket, we're going to factorize as an easy trinomial. So it pops up as an easy trinomial. Remember, how do we factorize easy trinomials? We look at this guy, we square root him, we would get an x there and x there. We look at the factors of -6, but these factors, one of them needs to be positive and one of them needs to be negative, right? And these factors need to add to give me a negative one. Remember? So they need to add to give me a negative one. So let me substitute these factors. So I'm thinking, what about a +3 with a -2? What do these give you? These give you a positive one. So the negative is not on the correct amount. It's not on the correct amount. Remember what I said? Negative needs to be on the bigger number. So in this case, the negative needs to be on the 3, because when you do this, that's how you end up with the -1. So the -3 would go there, and the +2 would go there. And this is your final answer of this intermediate trinomial. Let's have a look at another one. What about something that looks like this? 3x squared minus 21x minus 54. Again, we can take out a common factor, and 90% of the time your common factor will always be this coefficient there. 90% of the time. So if you take out a 3, then what we get inside of our bracket, we get x squared, because 3 times x squared will give me 3x squared. Here we get a -7, because again 3 times the -7x will give me a -21, and here we get a -18, right? And then we factorize our trinomial, the guy inside of the bracket. If you square root this guy, you get an x. Factors of -18 that add to give you -7. I am thinking a 9 and a 2, definitely, but the 9 needs to be negative and the 2 needs to be positive, because this is how you get a -7. So -9 in there and the +2 in there. And there we go. Easy, right? As soon as you understand the easy ones, the easy trinomials, then every other one after it will become second nature. All right? Let's look at this other one, which is slightly different. So previously I said 90% of the time it will always be that coefficient that you see in front. In this case, we don't have a coefficient. But what we notice is happening is that this exponent here is always a 2, but this time is a 3. This one is always to the power of 1, but this time it's a 2. And now this last one, there's usually no variable there, but this time we do have a variable. So actually x is our common factor that we can take out there. So we take out our x, we open our big brackets, then we say x times an x squared would give me an x to the power of 3, plus a 2x would give me back to a 2x squared, minus an 8 to give me back to a -8x. Then once I have that, I keep my x. Do not lose that x. Do not lose your common factor that you've left outside. Then at this point, square root that guy, I get an x, factors of -8 that add to give me a +2 since it's a negative and the middle coefficient is a positive, so the 4 needs to be positive and the 2 needs to be negative, and that's how you end up with the +2. So I put a +4 in there and I put a -2 in there. Alright, there we go. So now at this point we've kind of finished the intermediate ones and we've done the easy ones. Let's look at lastly the complex ones. Complex ones, do not be intimidated. They kind of follow from the easy ones. The only difference here is there might be a little bit of fractions here and there, but don't worry, it's nothing to be scared about. So what if it's a 3x to the power of 2 plus an 11x plus a 6? So we're having a look at this, and at the back of your brain, you're thinking, okay, cool, there's a common factor, but no, there isn't. There isn't a common factor that you can take out. 3 does not go into 11, even though it does go into 6. But remember, common factor has to be common in each and every single one for it to go out as a common factor. So what do we do then? What we can do is we can take this guy, the 3 that you see in front, and we can multiply him with that 6 that you see at the back. So what am I doing? I'm multiplying the 3 and the 6. And if I do that, the 3 goes away from there. And now I have this middle term that stayed the same, but a 3 times the 6 would give me an 18. So I get this new trinomial. And this new trinomial you can easily factorize. It looks like an easy trinomial. Factors of 18 that add to give you 11 is a +9 and it's a +2. But as much as you took this 3 and you multiplied across with, you have to come back in this step and divide with that 3. What do I mean by divide? I'll show you exactly what you need to divide. You need to divide this 9 by 3, and you need to divide this 2 by 3. And 90% of the time, right? I like using that because it's not always. But 90% of the time, what's going to end up happening is the first bracket can be simplified quite easily, or one of the brackets. It might not always be the first one, but one of the brackets can be simplified because 9 divided by 3 is just a +3. But one of them cannot. A 2 over 3 cannot be simplified. So what you would do in this case, you would take that 2 and you would multiply across to the x. Sorry, not the 2, the 3. The 3 that is in the denominator, you'd multiply it across to the x, and you would leave the numerator 2. And now this would be your final answer. I know that was quite a lot to take in, but let's look at another example. The same idea, but a different example. What if it looked something like 5f squared plus 59f minus a 12? So what if it looked like this? How do we go about solving something that looks like this? Again, there is no common factor. You should always check, is there a common factor? 5 does not go into 59, nor does it go into 12. So there's clearly no common factor. So what do we do first? We take this 5 and we multiply it with the 12. It goes away from there, and we end up getting 5 times 12 is a 60. Then now we've gotten this, we factorize this. Square root the f, you get an f. Square root the f squared, you get an f and an f. Factors of negative 60 that add to give you 59 is a positive 60 that is being added with the minus 1. And this is how you get to a 59. So one of my factors here is a 60. The other factor here is a negative 1. But remember, just as much as we multiplied with that guy, we have to come back and divide. You should never forget to divide these factors here. So I divide by the same number, which is a 5, divide by a 5 there, divide by a 5 there. And what's going to end up happening, 60 divided by 5 is just a 12. But the second one cannot be simplified, so you times it across to the f there, and you're going to get a 5f minus a 1. And there we go. That's how you would solve these types of trinomials. So at this point, I think it's making sense. Let's do one last one, and then we're going to wrap up the video. All right, let's take something that looks a little bit harder. So how would we factorize something that looks like this? It reads 18d squared minus 25d minus 3. How do we factorize something like this? Again, we take the 18. You can try this out yourself if you feel confident now. Take the 18, you times across. This will stay as a 25. Negative 25d. But an 18 times a 3 is a negative 54. Remember, it's an 18, but it's times in with the negative 3, so that's how you get the negative 54. Then in the next step, you factorize this trinomial. D there, D there. Factors of 54 that add to give me 25 is a negative 27 with a positive 2. Right? Then once I've gotten my factors, I just need to come back and divide with the same 18 there, and divide with the same 18 there. Right? And then now I've divided with 18. The first fraction simplifies to be a negative 3 over 2. So that's that fraction. The second fraction simplifies to be a 1 over 9. So always simplify them first, and then now we can times across. This one times is the d there to give me a 2d minus a 3. And then this one times is across as well to give me a 9d plus a 1. And now that is our final answer. And there we go. So class 10s, again, this is the different types of trinomials at this stage that you should understand, be able to solve, and really be good at solving them. So on that note, I will leave you and see you on the next video. Thank you.